Hello and welcome back to our channel. And today we are going to study relations and functions. And today is the lecture number one of it. We will gonna complete the whole chapter in short videos, so it will be helpful for you to revise not just the whole topic, but small parts also. So let's get started with relations. So before starting off with the relations, I just want to let you guys know what is the meaning of subsets and sets. As you guys already know, or I'll tell you what is set. Set is a group of numbers, or else you can say elements. Okay. And what is subset? Subset is a much smaller, or you can say parts of set. Okay. You can say it as parts of set is also called a subset. For example, let's take an example of a set. For example, 1, 2, 3, set A. This is a set A, right? Now, if I may ask, what if I take a set B, that is 2, comma 3? I can clearly say that B is a subset of A. How? Because each element of B belongs to A. What it means? That every element of B is already there in A. So B becomes a subset of A. Okay, so this is the definition of subset and set. So now that you are comfortable with subset and set, let's get started with what are relations. Now, talking about relations. So if I take a set A, for example, 1, 2, 3, 4, and 5, and one more set B, I take one more set B. For example, we can take it as 3, 6, 9, 10, 11. Okay. So if I just connect it, what do I mean by connecting it? Like 1 is somehow related to 6, 2 is 3 somehow related to 3, 2 is related to 9, 4 to 10, 5 to 11. So what is this? As you can see, what is this black colored line referring to? This is nothing but relation. What did I just say? That 1 is related to 6. That means it is a relation. They are related to each other. So, how to write it? So, to write a relation, we can write it as A cross B, which is equals to, then we write the set 1, 1 comma 6, because 1 is related to 6 in some way, right? Then we write 2 comma 9, 2 is related to 9, 3 comma 3, 3 is related to 3, and these both threes are not same. Okay, these are of different sets. 4 comma 10, 5 comma 11, and so on. So A cross B is a relation. Okay. So if I may ask you that how many subset of A cross B exist? Subset of A cross B. So subset of A cross B. Initially what we were doing, subset of this means this, and this. More smaller set of the main set are known as subset. Okay. So if we have to form subset of A cross B, then the simple formula, or we can say the direct formula for number of relations from A cross B is 2 raised to the power NA into NB. Okay, very important formula. Getting back to the formula, we can now subset of A cross B I was talking about. So it will be equal to, let's see, 1, 2, 3, 4, and 5. It will be equals to 2 raised to the power 5 cross 5. That is 2 raised to the power 10. How? Okay. Now, okay. So in forming the subset, either 1 comma 6 will be a subset. Like if I write A cross B dash, let it be the subset. So either it can contain this, okay, it can contain this, and rest will not contain. So this is a subset. This is a subset of this. So there are 2 raised to the power 10 subsets like this, and all the subsets are relation. Repeating once again, what did I just said? Any subset of A cross B, let me write. I said any subset of A cross B is a relation of set A to set B. Okay, and how to form this? That A cross B will contain more elements. Okay, don't you think like this is over? This is not over yet. This will continue. Okay, because A will somehow connect to 3 also. Okay, A will connect to each element of B, and this will go on. That's why the value is so much big. Otherwise, you will see that there are 5 elements. So there will be like these two, these two, these two. So no, it's not like that. It is very, very big. Okay, so this is relation, this is set, and this is subset. Now, now we are moving on to types of relations. Okay, relations. So there are majorly 3 types of relations. First one is a reflexive reflexive relation. Next is our symmetric relation, and the last one is a transitive relation. Okay, so what are they? Okay, let me explain. For example, take a set A, 1, comma 2, 3, 4, and 5, and set B, 1, comma 3, 9, 10, and 5. Okay, it's like this, set A and set B. Now I form a relation. Okay, relation might not contain every possible relation. Okay, we can take a small subset of it. So if I connect 1 from 1, 3 from 3, and 5 from 5. So 1 from 1, 3 from 3, and 5 from 5. So as you can see that both the element taken from set A and set B are same. Both the element taken from set A and set B are same. So such type of relations are known as reflexive relation. Okay, such type of relations are known as reflexive relation. So if A comma A belongs to the relation for all A belongs to A, these type of relations are known as reflexive relations. So the element taken from B, this is the element taken from set A, this is the taken from set B, and though both the elements should be same, such will known as symmetric, reflexive. Okay, now what is symmetric relation? Talking about symmetric, symmetric relation. Symmetric relations are such that if the set contains elements like A comma B, so it must contain elements like B comma A also. Okay, if it contains C comma D, then it must contain D comma C also. Such type are known as symmetric relation. Okay, you can see now symmetry is there. A comma B. If you put a mirror, you can see symmetry. B comma A. Okay, so such type of sets are known as the symmetric relations. Okay, so for example, let's take set A, 2, 3, set B, set B, we can take it as 2, 1, 6. Now relation 1 comma 2. Okay, 1 is connected to 2 and 2 is connected to 1, 2 is connected to 1. So this is a symmetric relation. Okay, so A comma B belongs to the relation R. Okay, this implies B comma A also belongs to the relation R for all A comma B belongs to A. Okay, such type of relations are known as symmetric relations, in which A comma B, if A comma B belongs to the relation, then B comma A must belong to the relation. Okay, so next we are talking about transitive relations. Transitive relation. Now, what does transitive, by hearing the word transitive, what does come in your mind? Of course, the word transition comes in your mind, right? Transitive, transition. So yes, it's similar. Suppose a relation R contains elements like A comma B, next B comma C, and next C comma A. Okay, so this is a transitive relation. Okay, how? I'll tell you. Imagine this as there are three places. You are moving from A to B. This represents moving from A to B location. Okay, so what will this represent? Moving from B to C location. And if you see, indirectly, you have reached from A to C. Okay, so this is representing A, B. This is representing B, comma C. And hence, this is representing A, comma C. So the relation in which this type of closed loop, you can say, is present are known as symmetric transitive relations. Okay, you can see there's a closed loop. Yes, yes, there's a closed loop. So I hope you guys got the gist of the topic and all the concepts are clear to you guys. We'll meet in the next lecture of this relation and function. Hope you like the video. Thank you so much.